Right, good day everyone.
Again, do the code.
Now we have a question here, WAEC 2025 WAEC number 1 question. And the question reads, given that U is X such that this notation is such that 1 is less than X and X is less than 3, where X is an integer, that means X has to be a whole number. Then P is X such that X is a multiple of 3. Then Q is X such that X is a prime number. And say where P and Q are subsets of U, that's U is the mother set. That means P and Q are gotten from what? U. Find P intersection Q complement. The next question is find P complement union Q. Then the third one is find P union Q or in complements. So we get down to that. Okay, we have these questions. So the first thing we want to do is enter the values for U, P, and Q. That's the first notion. So the first recommendation is let's get our U. I'd like to write it here. Our U, can you see me from there?
Yes, sir.
Our U is going to be what? They said where X is such that 1 is less than X and X is less than 20. 1 is less than X, so 1 is not inclusive. If they said 1 is less than or equal to, if they are given this, would have included 1. But they say 1 is less than X, that means X is greater than 1. So what are numbers are greater than 1? 2, 3, 4. And they say X is less than 20. So numbers are greater than 1 from 2 counting, then we stop at what? 19. Because they say X is less than 20. If they indicated this equal sign, we would have included 20 to have inclusive. But they just said less than 20. So I'm going to do 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. So this is going to be our what? Our U. Our U will be this. Now, if we come to our P, we say P is such that X is a multiple of 3. With respect to this entry, alright, so we have our U. Our U is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So that's our U, given this entry. And they say where X is an integer, that means it has to be a whole number. Then they said P is such that X is a multiple of 3. Between 2 to 20, what are the multiples of 3? Let's have that for our P. So our P is going to be what?
3.
What's about 3?
3,
6,
9,
12,
15,
15, and 18. So these are the multiples of 3. This is P. These are the multiples of 3. This is P. Then we have our what? Our Q. We say Q is a prime number. Under that condition, Q is a prime number. So what are the prime numbers? Under this, it's going to be 2, 3, 5, 7, 11, 13, 17, and 19. These are the prime numbers. So we have our U, P, and Q. Now the first thing they ask us is say P intersection Q complement. Now, for Q complement, one thing you want to, when they ask you to complement something, look at this. If I say A, if I give you this as universal set, U equals to what? 2, 3, 4, 5, 6. And A is the subset of U. And A is 2, 5, and let me do 7. Let me just pick up 7. A is 2, 5, and 6. And we have to find A complement. A complement. This is what you do for complement. Take out A from the universal set. Whatever is left is the complement. So A is 2, 5, and 6. So you cancel 2, you cancel 5, and you cancel what? 6. Whatever is left becomes the complement. 3, 4, and 7. So A complement is going to be what? 3, 4, and 7. That's what A complement. So I'm just trying to explain complement because we're going to do Q complement. So we're going to take Q out from the universal set. We're going to cancel everything that relates to Q from the universal set. Okay? We're taking that out. Okay, we just explained complements in NE using A as a case study. So now we are asked to complement Q. Only this is P intersection Q complement. It's quite different from this here. So we're complementing Q. So let's take Q out from the universal set. So we're taking 2, let's go. We're taking 2, 3, we're cancelling there, 5, 7, 11, 13, 17, and 19. So what do we have left? Whatever we have left becomes our Q complement. So what do we have left? We have 4, 6, 8, 9, 10, 12, 14, 15, 16, and 18. So this is our Q complement. So Q complement becomes a set of its own. These are Q complements. Now we are asked to intersect it with what? P. So P intersection Q complement. Now this is what you do. This is your P. This is your Q complement. Now the question is P intersection Q complement. Intersection means what occurs here and here. This is our P. This is our P here. This is our Q complement. So we are asking intersecting this and this one. So what do? We don't need to. Okay, I claim the Q, so we don't run into confusion. So these are the entries we need. We have entry for P and we have entry for Q complement. And I said P intersection Q complement. So let's go. What do we have here and here? That's what intersection is. So what entries do we have here and it's repeating itself here? So we have a 6. What do we have again?
9.
We have a 9. What do we have again?
12.
We have a 12.
15.
15.
And 18.
And 18. So this is our P intersection Q complement. This is our P intersection Q complement. Alright, the next question is P complement union Q. So we need to generate a set for P complement. We have P. So from P we can get the complement of it. So but we need a separate set for P complement. So we're going to use it in union with Q. So let's get our P complement first. Remember what I said about complement. Take whatever P is, take it out from the universal set. Whatever is left is the complement. So we are going to take out, we're going to cancel 3, 6, 9, 12, 15, and 18. So whatever we have left is what? Our complement. So what do we have? We have 2, 4, 5, 7, 8, 10, 11, have an 11, 13, have a 13, 14, have a 14, 15, have a 16, 17, and 19. And this is our Q word complement. This is our Q complement. This is our P complement. Sorry, our P complement. So I'm going to clean the Q out. So we have these two. So these are. Alright, so I just cleaned our P out because we need both P complement and Q. So we have our P complement and we have our Q. So those are the two things we need. So we can enter our answer. Can you see me from down here?
Yes, sir.
So I write my Q, it's P complement union Q. That means we're taking everybody here and here. So let's go, we're taking everybody. So we have 2, 3, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, and a 19. 2, 3, 4, 5, 7, 8, 9, 8, 10, 11, 13, 14, 16, 17, and 19. And this is our P complement union Q. That's it. Alright, the next question here is P union Q all being complemented, all in complement. P union Q all in complement. Different from this, different from this. The both are being complemented. Now, this is what you do. You need to get this set inside. You need to get whatever is inside first. They are complementing whatever is inside. So let's get our, that's why I wrote our P and our Q. So what is P union Q? We need to get the P union Q first. You need to get this set. Yeah, that's what we're going to complement. So now let's get P union Q. We're taking everything in P and Q. So let's go. We're taking what? 2, 3, 5, 6, 7, 9, 11, 12, 13, 15, 17, 18, and 19. 18 and 19. We have 19 in Q, right? So we're taking everything. So this is P union Q. Now, given this information, we have our P union Q. So that's what I asked you for. That P union Q or complement. So that's what we'll do. We're going to complement this. So we're going to take this out from the universal set. Whatever is left is going to be our P union Q or complement. So we're taking 2, 3. Let's go. Let's take it out. We're taking out. We're counting 2, 3, 5, 6, 7, 9, 11, 12, 13, 15, 17, 18, and 19. Now, our P union Q, all complements is whatever we have left. What do we have left? 4, 8, 10, 14, and 16. Then, this is our P union Q, all complements.